So, hi guys, welcome again to another video, and for this video I'll be discussing the summary of chapter 5, which is the Ethernet. So, let's start. Ethernet encapsulation. So, here we have two types of sublayer. We have the LLC sublayer and the MAC sublayer. So the LLC stands for the logical link control sublayer. So it provides the logic for the data link, and it controls the synchronization, flow control, error checking function of data in link layer. So while in the MAC sublayer, the MAC stands for media access control, and it provides control for accessing the transmission medium. So it is responsible for moving data packets from one network interface cards to another across a shared transmission medium. So the data encapsulation here has three types: the frame delimiting, the addressing, and the error detection. So for frame delimiting, we have it is a process provides important delimiters that used to identify the group of bits that make up a frame. So that delimiting bits provide synchronization between transmitting and receiving nodes. So for addressing, we have encapsulation process on the layer 3 CDU, PDU, and also provides data link layer addressing. And for the error detection, each frame consists of failure used to detect any errors in transmission. So for the media access, it is a second responsibility for the MAC sublayer, and is responsible for the placement of frame media or removal of frames from the media. So for the next one, we have the frame forwarding methods on Cisco switches. So here we have the store and forward switching and the cut-through switching. So for the storeward, it will wait the entire frame has arrived prior to forwarding it, and this method is the entire frame in memory. Once the frame in memory, the switch checks the destination address, the source address, and the CRC. And if there is no error present, the frame is forwarded to the appropriate port, and this process ensures that the destination network are not affected or truncated frames. And for the cut-through, it will begin forwarding the frames as soon as the destination address is defined. The difference between the cut-through and the store forward switching receives the whole frame before forwarding. Since the frame errors can be detected by reading the destination address, cut-through may impact network performance by forwarding corrupted or truncated frames. These bad frames can create broadcast storms wherein several devices of network responds to the corrupted frames simultaneously. So, when the switch receives the frame, it stores the data and buffers the complete frame has been received, and the switch acts upon the data as soon as it is received, even if the transmission is not complete. So for now we have the full duplex and the half duplex. So the difference between the full and half duplex is with half duplex mode, each transmitted character is immediately displayed on the monitor. So if the device is operating in full duplex mode, transmitted data not appear on the screen until it received in return. Full duplex Ethernet does save time when compared to half duplex because it alleviates collision and frame retransmission. Sending and receiving are separate functions, creating a system where there a full data capacity in each destination. So in contrast, half duplex can be used to conserve bandwidth. So for the next one, we have the destination on the same network. So here we have the physical address, the MAC address, and the logical address. So for the physical address, the MAC address is used for Ethernet NIC to Ethernet NIC communication in the same network. So for the logical address, for the IP address, just to send packet from the original source in final destination. So the physical address has the destination MAC address, the source MAC address, and for the logical, it has the source IP address and the destination IP address. So for the destination MAC address, it is the MAC address for the file server in Ethernet NIC. So for the source MAC address, it is MAC address of a PC's Ethernet NIC. So for the source IP address, it is the IP address from the original source, which is the PCA. And for the destination IP address, it is a final destination the file server. So additional in this chapter, I'll be discussing the unicast, because there is also a unicast MAC address here. I'll explain to you the difference of that three. So for first one, we have the unicast, just like the same in the previous chapter. The unicast is a unique address used when a frame is sent from single transmitting device to a single destination. So here we have the source host sends data and it goes to the switch, and it will also send on a one PC. So for the broadcast, we have the contains the IPv4 address that has all ones in the host portion. This numbering address means all the hosts of local network will receive the packet. So here the source host will send data and it goes to the switch, and all of the destination host group that are connected to the switch will receive all the data. And for the multicast, it allows a source device to send a packet to a group of devices. So just like what I've said in previous chapter, the source host sends data and it will go to switch, and some of the destination host group will not receive the data, but some of the destination host group will receive the data. So that's all for this video. Thank you for watching. See you again on the next video.